Okay, hi everybody. Today we're going over function notation. So here you have some machines. We have the F machine. We have the G machine. We have the H machine. And these are the rules. This is the rule for the F machine. So that means to take the input and add 5 to whatever you put into the machine. So it's all about inputs and outputs. We're going to be putting stuff into the machine. So that means X is going to get replaced with whatever you're putting into the machine, and then it equals the output. So we're putting things in and out of these machines, and the rule tells you what to do to the input. So this one says to take the input and add 5. This one says -3 times the input. And we'll look at the last one in a second. So this is basically what it means. It's just understanding input, output, and notation. So if I ask you to drop into this machine a -12, then that means the X is replaced. So the X gets replaced with -12. That's what it means. So that would give us -12 plus 5. And what is -12 plus 5? That is -7. So when you put -12 into the machine, you get out -7 when you put -12 into the machine. So we can write that using this fancy notation. So F is the function. We put a parentheses, and what goes here is what's going into the F machine. So -12 is going into the machine, and then we say what's coming out of the machine is -7. And that's what that fancy notation means. So it's input, output. Let's look at the next one. What if we drop into this machine a -2? So remember, this means -3 times the input. The input is your X, so that means X gets replaced with -2. So that is -3 times a -2 because they asked us to replace the X with -2. And a negative times a negative is a positive, so that means a +6 is going to come out of that machine. So we can use this fancy notation that says G was the machine we were using, and what we put into the machine was -2. What we put into the machine was -2, and what we got out of the machine was 6. And that's what this notation means. So this is your input. This is your output. And the G is the name of the machine that you're using. And the 3X is called the rule of the machine. So that is the rule of the machine. So understanding the anatomy of a function. So that's called the rule of the machine. So if we look at this one here, if I ask you to put 2 into the machine, notice there is no X. So it doesn't say 7 plus your input. It doesn't say your input take away 7. It doesn't say 7 times your input. There is no input. There is no X there. So that implies, since there is no X, that means no matter what you put into the machine, 7 is coming out. So if you put 3 into the machine, you would still get 7 out. If you put 5 into the machine, you'd still get 7 out. And so this one is a special type of function. This is called a constant function. And we can say that name of the function is H. If we put 2 into the machine, we will get 7 out. If we put 5 into the H machine, we will get 7 out. No matter what we put into the H machine, we will always get 7 out because there is no variable. And that is known as a constant type function. So it's kind of a special case in that there is no X in there. So that's basically your inputs and outputs and your function notation. So if I was to give you J parentheses 7, what does that mean? That means 7 is the input into the J machine. So that means we're putting 7 into the machine. We don't know what the rule is, and we don't know what's coming out, but we do know that 7 is going into the J machine. If I say J of X equals 7, that means we're using the J machine. We still don't know what the rule is, and 7 is coming out of the machine, so this is your output, and your X is your input. So whatever is in the parentheses is always going to be your input. So understanding what the notation means. Let's look at another problem. Here is 2 given functions. The function f is negative x plus 2, and g of x equals x minus 7. What if I ask you to find g of 5? And that's how you read that, by the way. That is read g of 5. It does not mean g times 5. So that is asking you to put 5 into the g function. So that means they want us to put 5 into the g function. So that becomes 5 take away 7, and isn't 5 subtract 7 negative 2. So we can say that when you plug 5 into the g function, you get negative 2 as its output. So when you plug this in your put, you get negative 2 as your output. If you want, some people, it helps if they draw a picture. So if you wanted to draw a diagram of this, this is your g function, right? That's your g function. The rule is x minus 7 is the rule. So this is your rule. So x minus 7 is your rule. And they asked you to put 5 into the function. So they wanted you to put 5 into the function. So that means that we put 5 where the x used to be, and then that gives you negative 2. So if you need to, you can draw a picture of what it is. But do you really need to draw a picture? What if I ask you to find f of negative 4? That's how you'd read that. F of negative 4. So that means you're using the f machine. So that means we're going to be using this function, because this is the f function and this is the g function. And this means we want to plug negative 4. So we want to plug negative 4 into the f function. So negative 4 needs to go in place of that x. We need to put negative 4. So that gives me a negative. Sorry, it's a little sloppy. Go back and rewrite this a little bit better. Notice how I'm putting a parentheses where the x used to be, and I'm putting negative 4 there. And I'll erase this, it's in the way. And then it's just order of operations, right? What's a negative times a negative? Isn't that a positive 4? And isn't 4 plus 2, 6? So when you plug in to the f machine and you drop a negative 4 into the f machine, and the rule is negative x plus 2, you will get 6 out of that machine. And so we can say when I plug in negative 4 into the f machine, I get 6 out. So this is your output. And negative 4 is your input. You can even write your input-output as an ordered pair. So remember, x and y is an ordered pair. X would be your input, and y would be your output. So we could even write that when I put negative 4 into the f machine, I got 6 out, and I could plot that, because this is your input, and this is your output. So 1, 2, 3, 4, negative 4. 1, 2, 3, 4, 5, 6. So negative 4, 6 is right here. So negative 4, 6 is right there. So there has an input of negative 4 and an output of positive 6. We can even plot the input-output using a coordinate plane. And we're assuming that you guys know how an x and y axis. So your x-axis is your input, and your y-axis is your output. And this is location that has negative 4 as the input and positive 6 as an output. That's the location that has that coordinate. Now let's look at a different type of problem. So this particular problem, we're given 2 functions. We're given an f function and we're given a g function. And we have 2 different rules. So remember, for the f machine, it says the rule is 2 times the input plus 1. where the g function, the rule says to take the input and divide it by 3 and then subtract 1. Those are called the rules of the function. Again, it might help you to draw a picture. In this particular problem, don't they want us to use the g function? So aren't we going to go to the g function? And notice that what's inside the parentheses is always the input. And 8 is the output. So they want you to determine if 8 is coming out of the machine. They're trying to figure out what do you have to put is the input. If the rule is x divided by 3 minus 1, what would you have to put into the machine to get 8 out? So the way that we're going to do that is we're going to set up an equation. And we're going to say the rule is x divided by 3 minus 1, and we want to get out of that machine, right? We want to get out an 8. So we created an equation. And once we create an equation, can't we use our algebra skills to solve that equation? So don't we undo subtracting 1 by adding 1? And then don't we undo dividing by 3 by multiplying by 3? And isn't that how we get the answer is 27? So 27 is what you would have to put into the machine to get -1 out. And I can prove to you over here that if we plugged in 27 into the machine, doesn't that mean that 27 goes where the x used to be? And isn't 27 divided by 3, isn't that 9? And isn't 9 take away 1? Isn't that give you 8 when you get out? So I just proved to you that 27 going into the machine does indeed give me 8 out. So that's how you do that problem. So again, this time they didn't give you the input, they gave you the output. So what if I say find x, so that in other words, they want you to find the input when they're telling you the output is 13. So we're using the F machine, so that means we're using this problem, and 13 is the output. And they want us to find the input. So F is the function. The rule of the machine is 2x plus 1, and they want us to get 13 out. And so they want to know what would you have to put into the machine? What would the input be to get 13 as an output? So we're going to set up an equation, and we're going to say the rule is 2x plus 1, and we want to get out of that rule 13 out of that rule, or out of that machine. Once we develop that equation, then we can use our algebra skills to solve. We can undo adding 1 by subtracting 1. And then we can undo multiplying by 2 by dividing by 2. So 6 is going to be the input necessary to get 13 out. And if we wanted to, we could actually write this as 6 was going in, comma 13 was coming out. So we can also use what's called an ordered pair to write the input and the output. So the x is the input, and what's coming out of the machine is the y. So we can also write it the same way. And this is known as function. I call it fancy function notation, where 6 is what's going into the machine, and 13 is coming out of the machine. So it's all about inputs and outputs. And F is the style of machine, and that is read F of 6. That does not mean F times 6. That means F of 6 equals 13. So 6 going into the F machine, 13 comes out. Those are the harder questions. Again, the easier questions would be if I just said F of x equals 2x plus 1, and I said find F of -3. Remember, -3 is the input. So that means I'm just going to put -3 where the x used to be. So x comes out of the game and -3 goes into its place. order of operations says you multiply, so that's -6 plus 1, which would be -5. So you get -5 out of the machine. So again, it might help you to draw the picture if it helps you, right? The rule was 2x plus 1. They asked you to plug in -3 into the f function. That's what that means. That's your input. So when we plugged in -3 into the function, that was 2 times -3 plus 1. That turns out to give you a -6 plus 1, which is a -5 out. So it's about the input and the output. I hope this helps about function notation and input-output. So there's your input. We're using the F machine. -3 went into that machine, and we got out of that machine. Got to put in equals. We got out a -5. Output and input. Right? Okay, I hope this helps.